today I'd like to walk you through my experience building and running multi-tenant systems with a focus on observability. So who am I and why would you care about any of my opinions on observability? The two most relevant things that I did, I started the Husky project at DataDog, which is a replacement for DataDog's legacy search and analytics system. It's been in production for a while now. But other than that, I'm also one of the co-founders of Warpstream, where we're pioneering, quote unquote, a new software deployment model called Bring Your Own Cloud that has a lot of observability challenges associated with it. We were recently acquired by Confluent, and I'm a director of engineering there now. So, as I said, Husky was a replacement for Datadog's legacy search and analytics system, and while I was there, I got to experience the pain of a lot of different customers. You know, Datadog's customers come to us with their challenges, obviously send us their data, and I got to learn, you know, what are the right ways and the wrong ways to do observability. And also internally, the teams at Datadog are obviously very good at using their own products, so I got to learn a lot from my experiences there. But besides that, Husky itself was a massively multi-tenant system. We had to juggle a lot of hardware resources on behalf of our customers and do it in a way that was cost effective. But also the customers, Datadog is kind of a premium product, so the customers are very demanding in terms of what they'll accept from a performance and stability perspective. So now what about Warpstream? I'll explain a little bit about what it is. It's a drop-in replacement for Apache Kafka that runs directly on top of object storage like Amazon S3. It's auto-scaling in the sense that the compute nodes are all stateless. There's no cross-AZ networking cost because that's all baked into the cost of using object storage. And it's extremely easy to use. We just give you a deployment in Kubernetes terms as a Helm chart, and you're off to the races. So as I said, it's delivered as bring your own cloud. Now, some people might know what that means. Some people might not. It's also not a very well-defined term. And what I take it to mean is that we run the control plane in our cloud account, and the customer runs the data plane inside theirs. So the data in our terms would be like the Kafka message bytes. That stays all inside your VPC, but we run some type of control plane that makes it easy to use and gives you the magical stateless auto-scaling stuff. We handle all the hard parts. I'm sure there are a lot of other definitions, but that's the one that I mean. And what that necessitates is that we need to understand both our own environment very well, and we need to understand our customer's environment very well. Our customers run Warpstream on a variety of hardware configurations. Like for example, they don't listen to us at all. We've had customers who run Warpstream on Spot instances, for example, which is running a thing that looks like a database on Spot instances is definitely not recommended by any vendor, but they do it and they expect it to just work because that was the thing that we sold them. It's like the stateless auto-scaling Kafka. Why can't I run it on Spot instances? So in order to make this stuff happen, we have to gather the right telemetry from our customers' environments to help them when they back themselves into a corner. And we can't just like remotely upgrade their code to add some logging or something after the fact, because that would kind of violate the whole premise of the BYOC model from a security perspective. Like, you control what's going on in your account, and we control what's going on in ours. So that means we had to get really good at observability. And this word also means a lot of different things to different people, but what I take it to mean is that you're instrumenting a software system so that you can understand it after it runs. The instrumentation part takes a lot of different forms, and I'll talk about what those are today. But there are a lot of tools and vendors on the market that are going to try to sell you some type of auto instrumentation magic. But after you install that, you'll never have to debug a production issue again. That's not what I'm going to talk about today, because that stuff is all fake. But what observability must be is a continuous feedback loop between the code that you're writing, the environments that are constantly changing. Let's say you're moving from VMs to Kubernetes, for example. That's a major change in your environment that's going to necessitate some change to your observability. You're going to add new features, or you're going to deprecate features. All of this stuff is happening in your environment in a way that's going to change what matters to you from an observability perspective. You're also going to onboard new customers and new workloads that are going to make you realize you actually have no idea what's going on in some critical bit of code, because it was never stressed before until you onboarded your biggest customer. So at the same time, you're going to be forced to deal with constraints. The biggest constraint that's going to prevent you from just collecting everything, as people would love to do, is budget. The cost of observability seems like it should be going down every year. It's kind of like a basic data processing problem. Why is the cost not going down every year? But as I'm sure most people in this room are aware, your DataDog bill probably did not go down this year. It probably went up. So even with infinite money, let's ignore that for a second, eventually you're going to run into runtime overhead of just trying to collect more and more stuff. You're not going to be able to continually collect your way out of the problem of having that continuous thinking feedback loop with your system. You can imagine trying to capture every change to every local variable and every network packet in full fidelity, but your system will just fall over. And the worst, in my opinion, part, because it's the most annoying, it's the thing that you're interacting with as a person, is the tools are fairly rigid, especially in the types of queries that they allow you to express. The tools are not flexible. Most of observability tools don't just expose the ability to run arbitrary SQL or something like that. It's much more locked down because they're usually trying to sell you a multi-tenant thing that they have to be able to understand the performance of very well. If you can run arbitrary SQL, that's usually a little bit more helpful, but you probably can't. So unlike inside of Antithesis, it's also always backward looking. If you're not logging something at the right moment that something critical occurs, it may just be lost forever. So you need to plan ahead and use your intuition to understand what things are going to be important in the future, and how can I collect them in the right way now that when I am looking back on it later, I can understand it. So, it's tempting to say, okay, I'll just go add logging when I need it. If there's some issue, I'm just going to go add logging, I'll deploy a new version. But if you're in the middle of an incident, that's potentially an even more dangerous operation to perform. So even if it's tempting to say, oh, I'll just go add logging later, it can end up being very dangerous. So what's so special about observability in a multi-tenant environment? When I say multi-tenant, I mostly mean in the context of like an enterprise software environment where the size of the tenants and the scale of the tenants can vary pretty dramatically. And no two tenants are going to use the same features in the same way. Some tenants are going to stress one dimension of your system, another tenant is going to stress the other dimension, and they're doing it at the same time. So you need to be good at both. And I mostly have an infrastructure software bias, but I think most of this will generalize outside of infrastructure. So the first archetype of a customer I'll talk about is an enterprise customer that has an extremely demanding SLA. They're probably not your biggest customer by volume, and they're not actually stressing your system that hard. But when they do have an issue, they want help immediately, and they want their problems fixed immediately. You might also have a viral app as a customer that you never heard of when they originally signed up, but they 100x'd their traffic overnight, and you would have wished that they would give you time to do capacity planning, and you could have just moved them on a dedicated infrastructure before they had their big traffic spike, but they didn't, and now their load is crushing you. So my personal favorite example would be a customer that is extremely seasonal. This would be like e-commerce. They probably don't even know that you exist as a vendor for them except on Black Friday and Cyber Monday. So they're, you can at least pre-plan for them, but they're still going to crush you with their traffic. Something that's a little bit more relevant for folks on the sales or go-to-market side would be potential customers that are currently going through POCs with you. That would be very important if those deals closed. How well does your system handle a brand new account that just signed up doing a load test? Do they trip all the rate limits that you've put in place to protect yourself? And do you even know that they are tripping them? It's a very bad experience if a customer signs up and they want to do a load test because they think, obviously they've planned for me to do my POC, and they hit a rate lit that makes you look unscalable right off the bat. So in order to build a successful business, again, bit of an infrastructure bias, you need to support all of these workloads well. And I can't really tell you how to do this. I can't solve all of your problems for you. So we should reframe the question a little bit to, how will I gather the right information and context to solve customer issues faster? This should be your constant thought process in the back of your mind as you're writing and, arguably more importantly, reviewing code. For some feature that I'm adding, how can I prove that it's running correctly in production? And when a failure happens, how do I know if it's cause X or cause Y? So these are my bag of tricks for how to do observability, quote unquote. I'll try to explain what each of them is if you haven't heard of them, and how I use them in some more detail. So assertions are probably familiar to most developers. They're pretty commonly used in tests, but I think that they're way underutilized in production code. A lot of people explicitly disable assertions in their production code because they sound very scary. Or the way that they write assertions is the assertions only happen inside tests. Like they're not even in the production code at all, so you have no chance of seeing them. And the way that we use assertions at Warpstream is the assertions that we write, we run them all the time in production. And it sounds a little scary, and I'll try to explain how we make that less scary and get the most value out of them. When assertions are easy to write, you will write more of them. It's kind of a natural side effect. So the first step is making them not scary. And the thing that scares people is that if I have some edge case poison pill thing that a free trial user signs up for and they start just blasting all my servers with, and some assertion fires, and now I have a full regional outage. That's people's worst case fear about running with assertions in production, basically. And the way to make that less scary is try to modularize your system into components that are easy to restart. That's the way that you make it less scary. And I can't prescribe exactly how you do this in your language or in your runtime or whatever, but in the context of Warpstream, what we do is we make every component a single tenant actor that we place into a shared pool of compute. So if we hit this poison pill edge case thing that causes an assertion to fire, we just make that actor gracefully exit, and it might get restarted on some other compute process, and that's fine. It might fail again there later, but what it doesn't do is it does not, cause the process to exit and then leave the load balancer backend set and cause a full regional outage. It kind of isolates the failure into the right spot. So that requires some upfront thought. It may not be possible to retrofit onto your system in exactly the same way. But if you are just, you have a stateless RPC server or a web server, this is probably easier to adopt than you might think. And this is the potentially even more controversial part, but you really need to make them page you. This is the trick that gets the feedback loop going of problems in production means I get paged and annoyed, and then I go fix them. So you have to, this continuous feedback cycle is what really makes the assertions useful. And the trick there is just don't make them paging in a development environment or a staging environment, so people aren't getting paged for noisy things while developers are iterating, but once they're in production, they should page you. The way I've seen most folks write assertions is, unfortunately, just error happened plus stack trace. They're kind of not very useful in a production context where you're trying to understand what happened plus why. Like, parameter foo must be greater than 0 was -1. That's like an assertion that would be very useful in the context of a unit test, where you have the ability to use a debugger and step around and figure out what the cause is. But when you're in a production environment, you need way more context than this. Like for that parameter foo, was it loaded from a file? Which file? When was the file loaded from disk? Maybe you're reloading config in the background constantly. You need to add this type of information to your assertions, which feels a little weird when you're doing it at first, if you're used to writing them only for testing purposes, but it's much more useful in production. So this is a real example of an assertion from Warpstream. Whenever we create a new prepared statement or run a one-off SQL query, it gets fed through something that checks that every SQL statement filters by tenant ID. This is like a security-related assertion. And it prevents a lot of silly mistakes. Maybe you use an ORM and you can enforce this some other way, but we're doing this on handwritten SQL. And it prevents a lot of potentially embarrassing security issues that we catch in CI before they even make it to production. So switching gears over to logging, this will be much less controversial, but I think this is the most powerful signal of the 4 that I talked about in the beginning. So you understand what logs are. Everybody understands what logs are, but you're probably not using them to their full potential. And the reason for that is a lot of people are logging just text. They have some garbage that formats a bunch of strings together, and it's impossible to do anything with. And modern logging tools can do way more than just grep. So you should start adding structured data, and preferably as JSON, since that's the most widely supported among the tools. I'll take a quick detour to talk about distributed tracing, because it's basically just logging with extra steps. Tracing provides some value if you're in a galactic constellation of microservices environment. That outside of that, you don't get a lot of value from them. They're mostly just a less feature-rich form of logging. But they are useful in the extremes. So you sprinkle around some spans in the right places around the boundaries of your system, and it helps you answer questions like, what does my slowest non-failing request look like? It's inherently a visual question, in my opinion, and looking at traces can help you identify some weird pathological behaviors that maybe you had never seen before. But again, this is just in the extremes. Looking at a random trace of a successful request is probably not going to provide you much information. Another reason why I don't recommend tracing, putting too much investment into tracing, is that the tools are generally very bad. Trace visualizers, they fall apart after 100,000 spans. And if they don't, what are you going to do looking at this graph of 100,000 spans? It's not particularly useful. And the thing that could make them more useful is the ability to aggregate or perform pattern matching on chains of spans, but no tool lets you do this. You're stuck back in, I hope you can write arbitrary SQL. So back to logging. You got to get to JSON. You need to structure your logs. If you can't do that, there's nothing I can do to help you. You're going to have a very hard time getting any value out of them. And the way that I recommend using logs is to make one log per thing. And I don't know exactly what your system does, but a good example of a thing would be like an RPC. So you make one log per RPC invocation. So in Warpstream, we have a lot of things that we call schedulers, which run in the background, which push tasks onto some shared queue. We have a bunch of these things, and usually we'd log once per iteration of the scheduler with a bunch of statistics we gathered along the way, along with the actions that it took. It also serves as a heartbeat for us to let us know that that scheduler is still running. The one log per thing approach I found that to be about the right granularity, because usually those things correlate with money somehow, and then you can understand how logs are going to impact your budget. You should enforce minimum standards and conventions in your logs. The way that we do this at Warpstream is we created a library that when you want to log the tenant ID field, when you want to add that to a log, there's a function that you call that makes sure that everybody has tenant underscore ID and not tenant capital ID. These types of conventions that you can enforce across your whole code base will make it so that when you're moving from context to context within your system, looking at the logs for just one tenant, you can see everything together. And it generalizes to other stuff too, like how you define logging the availability zone or the host name. Making sure that you have conventions for all of these makes logs much, much more usable. It's super tempting to let vendors auto instrumentation stuff do this for you. And maybe you should. It's really easy. That part is helpful. But you need to resist the temptation to rely on it as your primary source of context that you're adding into your logs. And the reason for that is kind of obvious, which is that the auto instrumentation only knows about common universal stuff like web frameworks. It's very easy for them to add auto instrumentation for web frameworks because they're basically all the same. But your business is not a web framework. So you need to actually add the context about your business and what your applications are doing in order to make it useful. So feel free to turn it on, but it's not where most of your interesting insights are going to come from. The best person to handle the one log per thing approach is the developer who originally wrote the code. They can decide what was important at the time that they were writing it. They can get all of the right context in there at that point. And when you're reviewing code, you should push back if you feel like they weren't following the best practices of, I need one log per thing, I need to gather detailed context along the way while this thing is executing. You should feel very comfortable pushing back and saying, I feel like once this gets to production, I don't know how I'm going to understand it or how you're going to understand it. It's the practice of getting logging inserted at the moment when code is written rather than after the fact will add the richness of what the developer originally had in their head at the time instead of what you hoped would be useful after the fact 3 months later. Every log should tell a complete story. If you sprinkle logs all over the place, it's error code X occurred, successfully processed one item. If you start just sprinkling these all over the place, first of all, you're going to explode your budget, but you're never going to be able to understand the why of errors occurring or performance problems, things like that. Too many of these small individual events will make too much noise. And again, maybe if the tools were better, you could resolve this issue. But because the tools are so limited, one log per thing that tries to tell a complete story is, you just have to have it. Otherwise, you're not going to get any understanding out of your logs. So another example from Warpstream to explain what I mean. So the process of ingesting data into the system is kind of like this 4-step thing. We allocate a new file ID, which is a thing that can fail for reasons I'm not going to explain why. We serialize the records into a buffer, we flush the buffer to storage, and then we send metadata to the control plane. This is what I would call a thing, and we log it with a single log. So each step builds additional context on the previous step, like latency information, retry count for the things that can fail. We add timing for CPU-bound operations, like the serialization to the file step, for example. And we also gather other contextual information from the rest of the system, so not for just this one thing, but for example, we gather statistics about what's concurrently being flushed to storage at the same time. It makes it easier to correlate errors with load spikes, for example. I had an error, but there were also, there's a gigabyte of data still waiting to be flushed at the same time. It kind of adds more context. Sometimes you're operating in an environment where failures are expected. Like for example, when you're using S3, things are going to be slow and they're going to fail from time to time. did that failure happen because I hit a rate limit in S3? Am I running out of network bandwidth? Or is S3 just hard down right now? How are you going to know that? You can capture the error codes with the right information about, oh, I got a timeout versus I got a rate limit error, and you should be adding that information to the log as you go. This sounds like it would be a little challenging, but the way that we did it, and we've seen a lot of success with, is you can treat a single log kind of like a history, where if you gather an array of mini logs inside a single log, building up that complete story inside of it becomes a lot easier. You can't necessarily query that in an easy way, but just try to cram as much stuff into one log as you can so that you can tell that complete story. Once you've started building out this collection of really rich logs, your business intelligence and customer support functions are going to start using those logs, and they will become load-bearing at your company, because so much of the useful context of what your customers are doing is captured inside those logs. So a hypothetical example that I think it's pretty universal is you're monitoring to see how often your customers are performing some operation. That's because you say you want to measure the success rate of it. That's more of a traditional monitoring context. But in a business intelligence and customer support context, you can reuse a lot of that same information to say, the customer stopped performing this operation as frequently as they did last week. Does that mean that they're going to churn? You could naively say, yes, they are going to churn because they're doing something less frequently, but what if you had enough information in your logs to detect that they're performing that operation less frequently, but each time they do it, it's processing more data? This probably looks like they're doing cost optimization. They're not going to churn now. Maybe I can focus my energy elsewhere onto other customers. So the next trick in my bag of tricks is metrics. You've all used metrics. They're like the signal everyone gets started with when they start thinking about observability. Prometheus is a popular example of an open source monitoring system, but DataDog and a ton of other vendors provide this as a service. So metrics are just aggregated time series, and they usually have some type of labeling or filtering capability. They're usually used for kind of specifying coarse-grained rules like page me if the CPU usage on all my nodes goes over 80% for 5 minutes. The error rate is above 1%. Really basic stuff like that is usually how people get started with metrics. They're really easy to throw onto a dashboard. You can get a quick view of the overall system health, especially if you're someone who's coming in after the fact to run a system that you didn't build. Metrics are very valuable to understand what does normal look like. They're most useful, though, when you know what you're looking for in advance. And the problem with metrics, and the reason why they're the most useful when you know what you're looking for in advance, is that as you try to add more dimensions to your metrics, you're either going to inflate your cost or your memory usage, depending on if you're running something yourself or you're using a vendor, because every metric, when you add these dimensions to it, every unique time series costs money because it's like a combinatorial explosion of all the tags multiplied together. You've probably run across this limitation in a metric system before, which necessitates that you're going to have to remove some context. You can't add all the context that you would, as you could with a log in order to make metrics work financially. But the way that I found them to be most useful is they are an escape hatch for logs that are too noisy. Eventually your system will kind of settle down, become more well understood, or it's just been stable for a long time and you're trying to do cost optimizations. You can replace noisy logs with a few metrics that, say, measure the latency, the error count. There's all kinds of basic things that you can add to metrics to get out of the escape, to escape a noisy log. And then instead only emit the log when something fails, so that you have the full context when you hit a failure, but otherwise on a success case, you don't have to pay the full cost. So an example from Warpstream where metrics come in handy is a lot of customers want to monitor the lag on their Kafka consumers. And the way that they usually want to do that is they want to express that in terms of time instead of just an arbitrary, I'm behind by this many messages or something like that. They want to know I'm 30 seconds behind because my SLA on processing data is 30 seconds. So we provide this metric to customers, and they use the metric to fulfill this goal, but they immediately have to pivot over into logs in order to understand what happened, because it could be one of a dozen different reasons why their consumer application is lagging. But if we instead emitted this just as logs all the time, it would be extremely noisy, and because your consumer is not falling behind most of the time, it would be a huge waste of money for them. So my last trick is something that you probably understand what it is, but you probably didn't know that you can use profiling in production. There are a few vendors now and probably even open source tools, but I'm not super familiar with them, of a process called continuous profiling, where you're constantly profiling your services in production. It's really magic. If you haven't tried it before, I would recommend checking out some of these tools. Because before continuous profiling, you just ship your code to production and you wouldn't really have any way to know how it was performing other than just these random metrics that you decided to add. And say you did a load test and or you wrote a synthetic benchmark and you saw that you can do this much throughput, but you can't really get down into the nitty-gritty details of, oh, this function specifically is the reason why I'm bottlenecked at this moment. You'd have to sprinkle all kinds of weird timing logs all over your code to capture this, and it would be too expensive. But now you can just continuously run a profiler on your code in production, have those profiles be aggregated together for you, and displayed in it looks like a single node's profile in the UI, and the bottlenecks become very clear. It's not well supported in all languages and all runtimes, but in Go, which is what we use for Warpstream, it has excellent support. And the coolest feature in Go, and I think it's also available in Java, is that we can use an anonymous function to then call this real function that we actually want to call. And with that anonymous function, we can add tags for which tenant we're calling this function on behalf of. And then we can take those profiles and filter down to that tenant after the fact so that we can see the full context for a specific tenant. Now, a lot of times, stuff starts to get lost in the noise. Like we run, the way that Warpstream's control plane and data plane split works, a lot of the Kafka admin APIs, they run inside the control plane. So the stuff that's not processing customer data, it runs inside the control plane. When we're looking at that as an aggregated 10,000 foot view across all the customers, a lot of the stuff just looks like noise. The handler for the Kafka metadata API, which is part of the service discovery, is mostly just copying some bytes around. It's not that interesting in isolation. But a lot of these APIs do get called thousands of times per second in a busy cluster. And we can leverage the fact that we know not all of our customers use the product in the same way. They don't all take advantage of the same features. And that per tenant metadata lets us see things that we would have never been able to see before. Because when you're looking at your entire fleet, a lot of things get lost in the noise. But maybe anecdotally, customers have told you, this API is a little slower than I thought, or this API uses more memory than I thought it did. So there's anecdotally something going on. we can use those tenant-specific tags to dig down deeper and look at workloads we know are interesting. We can go look at our customers that we know stress this API heavily, and we can see, oh, there is actually something interesting here. When we zoom in a little bit and just look at the context for one tenant, instead of looking at noise, we're back to pure signal. So once things start to stick out again, and in the context of profiling, you can actually make big wins for individual tenants within your system that you would have never been able to see otherwise. And it's not just in our case, it's big wins from both. We can make things lower latency, more cost effective. It's also a win for our customers too, because they're running our code in their environment, so it's also saving them on their side. So that was my last trick. The thing I'd like to leave you with is that you get out of observability what you put in. In the same way as writing tests, it's kind of on you to decide what's important. There's no one-size-fits-all solution that's going to dramatically solve all of your observability problems. And you need to look at observability as a constant feedback loop between you, your systems, and your customers in the constantly changing environment, and keep things up to date. Don't just let your logs go stale. I don't think any of that should be a surprise, because that's basically what all of software engineering is that constant feedback loop in one way or another. But observability is no different. Thank you.